Okay, now we're finally going to learn about the 6 trig functions. And so we're going to learn about sine, cosine, tangent, cosecant, secant, and cotangent. And we're actually going to get our definition from a right triangle, okay? So we have a right triangle here, and the important thing about a right triangle is that it has one right angle, which is 90 degrees. Okay, and we're going to pick one of the other angles that's not a right angle to focus on. So here's our angle we're going to look at, and we normally use the Greek letter theta. Okay, it kind of looks like a circle with a line through it to represent an angle. So we'll always want sine of an angle or cosine of an angle. So remember functions, you always have one input, you have an input and then you get out one output. The input for the trigonomic functions are angles. We're putting in an angle and we're going to get out a number. Okay, now if we talk about our right triangle, we need to label the sides because we're actually going to get the values for sine, cosine, tangent, cosecant, secant, and cotangent by dividing the lengths of the sides. So the side that's across from the right angle has a special name that's called the hypotenuse. So it's always the longest side and it's always across from the right angle. The right angle is kind of opening up toward it. Now, we have to label which angle we're talking about, theta, because the other two sides that we're going to look at depend on theta. Now, you'll notice that theta is kind of sitting, is between the hypotenuse and another side. Okay, it's kind of, another side makes up that angle. And the one that it's there kind of sitting on, that it's right there, is called the adjacent side. Then, it's also opening up to a side, the side that's across from it, and we call that the opposite side. Okay, so for this angle theta, we have the adjacent side and the opposite side, and the hypotenuse is always the side across from the right angle. Now I'm going to call the hypotenuse H, and the adjacent side A, and the opposite side O. Okay, and we actually get, and we'll have numbers here, we'll have lengths. And to get sine of the angle theta, we take the length of the opposite side and divide it by the length of the hypotenuse. For cosine, we take the length of the adjacent side and divide it by the hypotenuse. For tangent, we take the opposite side over the adjacent side. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. So you see, for these three sides, there's actually, if you pick two of them, there's 6 possibilities of how you divide them. And this gives kind of a definition for all 6. So here, since you haven't seen these functions before, let me take a few minutes to explain. When you see sin, that means sine. Okay, so we don't say sin, it's sine, and you'll always have an angle that you're plugging into it. Cos is cosine. Tan is tangent. CSC is called cosecant. And you'll notice it's sine flipped. It's the reciprocal of sine. SEC is secant. And you'll notice it's the reciprocal of cosine. And COT is cotangent. And it is the reciprocal of tangent. Now, you'll really want to have this down of when do I take opposite over hypotenuse, when do I take adjacent over hypotenuse, and so forth. And there's a mnemonic device to help you, and it's called Sohcahtoa. So S-O-H-C-A-H-T-O-A. And if you go on YouTube, there's plenty of like little stories or songs to help you remember Sohcahtoa, you know, maybe about an Indian princess, or when I was in 7th grade, my teacher had one about an Italian guy who was going to go on a date, and so he was taking a bath, and he wanted to know if the bath water was too hot, so he Sohcahtoa, he like soaked his toe to test the water. So, you know, however you can remember Sohcahtoa, you know, you want to remember it. And what it tells you is that sine, the S stands for sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so if you remember Sohcahtoa, you can think, okay, S is for sine, O means opposite, and then over hypotenuse. So let's go ahead and put this into practice and do an example. So here we've got a triangle, and this is our right angle. I'm not very good at drawing the right angle thing. And we're told that one side is 5, the other one is 12. Now, we actually need to find this hypotenuse. And since it's a right triangle, we can use the Pythagorean theorem. Which is a squared plus b squared equals c squared, where c is the hypotenuse. So we take 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared, which means 169 equals c squared. And if we take the square root of both sides, we get that c equals 13. So this is 13. Now, notice we have our theta right here, and I want to label what the sides are, opposite, adjacent, hypotenuse, based on that theta. Now, the 13 will be the hypotenuse because it's across from the right angle. Now, remember, the angle is kind of sitting on another one that's not the hypotenuse, so making that angle, that's going to be the adjacent, and the one that's across from is the opposite. Okay, so if we want to find sine of this angle, think Sohcahtoa. Sine is opposite over hypotenuse. So we're going to take 5 over 13. And that would be our answer, 5 over 13. Now cosine is going to be adjacent over hypotenuse. So that's going to be 12 over 13. Tangent is opposite over adjacent. So 5 over 12. Now, Sohcahtoa doesn't help you with the other 3, but if you remember which ones are reciprocals of each other. So cosecant is the reciprocal of sine, so we just do 13 over 5. Secant is the reciprocal of cosine, so 13 over 12. And cotangent is the reciprocal of tangent, 12 over 5. Okay, so especially while you're getting used to it, I would look at your theta and label which sides are adjacent, hypotenuse, and opposite, and then use Sohcahtoa to help you find all of the trig values.